Hey everyone, I just wanted to make a quick little quadratic transformation video. So if you were absent on Thursday or Friday or both days before spring break, you may not have been there for the quadratic transformation lesson, or it's just been a while. It's been a few weeks since we've done quadratic transformations. So I just wanted to help remind you how to do that. So first I'm on Desmos, just graphing here. So in quadratic equations, we have the most basic original OG quadratic equation, and this is x power of 2, and this is called the parent function. This is called the parent function. Parent function. Okay? So you can see that it does not make a straight line. It makes this curve, this U shape, and we call this U shape a parabola. And if it's a parabola, then that means it is a quadratic function. Okay, so this is our OG quadratic function, the parent parabola. So we're going to look at comparing this original parent graph to a new graph. So on your Google form, you're going to see 3 questions to ask yourself. So we're comparing that y equals x squared, the parent graph I just made on Desmos. So question 1, you're going to have a new equation comparing to this parent equation. So with the new equation, where did the vertex move from 0? So vertex is going to this point here, that center of the parabola. So on the parent, it starts at 0, 0. So the vertex is the center of the parabola. The vertex is the center of the parabola. The vertex is the what? Very good, center of the parabola. Now the vertex is going to be either at the lowest point or it could be at the highest point if we flip this parabola upside down. So here the vertex is at the lowest point, and we call that a minimum when it's at the lowest point. Okay, so where did the vertex move from 0? Did the vertex move left or right, up or down? And then question 2, is that parabola a stretch? Is it narrower, or is it a compression wider than that parent graph? The equation has to multiply a number with x squared, such as y equals 4x squared. For it to be a stretch or compression, the equation has to multiply a number. And then did the parabola flip over upside down? So this first one I want to look at is this example here. So we have negative 3x squared. So I can make a second equation, negative 3x, and then squared. So we want to compare. So question 1, where did the vertex move from 0? Well, for this blue graph, did the vertex move from 0? Yes or no? No, it did not. So let's look at our question 2. So the equation has to be multiplying a number. So let's see. Is this equation, does this say negative 3 plus x squared? Is this negative 3 minus x squared? No, it's multiplying, right? So we can see that it could be a stretch or compression since it's multiplying a number in the equation. A stretch is narrower, skinnier. Compression is wider. So here's the red, here's the blue. Did the blue graph get narrower or wider? Narrower or wider? Which one? Very good, narrower. So we can see that this would be called a stretch. And then last question, did the parabola flip over? Do we have a reflection? Yes, we do. Notice it's not a U anymore. It flipped upside down. So we call that a reflection When it flips over, it's called a reflection. What is it called when it flips over? A reflection. Very good. So now let's try another one before we go on to the other pieces. Let's just do another one like that. So on your form, it's going to be question 2, part E. Question 2, part E. So we have 4x squared plus 2. We're always comparing with the parent. So always leave y1 as x squared every time. Always leave y1 as x squared. That's the parent that we're going to compare with. But the new equation was 4x squared plus 2. So that's going to go in y2, 4x squared plus 2. Okay, so now let's answer those 3 questions. So our transformation questions. Question 1. Where did the vertex move from 0? Left or right, and up or down? So let's look at the middle of the parabola is the vertex. Okay, so here's our parent from 0. Let's see where the vertex moved from 0. Did that blue graph move to the left from 0? Or to the right from 0? Yes or no? No, it did not move left or right. Let's see. Did that vertex move up or down from 0? Which one? Very good. It moved up. It moved how many up? From 0 to 2. How many up? 2. Very good. So we would know that this has to be up 2. It did not move right, so it can't be either of those, right? So it's got to be either up 2 or up 4. Okay, so to figure out now, it says stretch by 4, stretch by 2, no reflection, reflection. So let's see. So to be a stretch or compression, our equation has to multiply by something. It's adding 2. Is it multiplying by anything? What number is this equation multiplying by? Yeah, good job. It's multiplying by 4. So since it's multiplying 4, we know it's a stretch or compression. So just to give you that visual in our questions, stretch means narrower, compression means wider. So did our new graph, the blue graph here, the blue graph, did it get narrower, skinnier, or did it get wider? Which one? Narrower or wider? Very good, narrower. So since we know it's going to be narrower, then that means it's called a stretch. But let's be specific. Stretch by what? What were we multiplying? Were we multiplying 2? Yes or no? No, we were not multiplying 2. What number were we multiplying in this equation? Yeah, 4. And then while we're here, that last question, did the parabola flip over? Did it flip upside down? No, so no reflection. So your answer on question 2, part E, is going to be up 2, stretch by 4. We were multiplying 4, and no reflection. Very good. Okay, the last thing I want to go over is just domain and range. So on breaking down a parabola, first you have to know the vertex. What is that middle point? And is that vertex at the highest point or is it at the lowest point? So on this particular equation, 4x squared plus 2, the middle of the parabola is 0, 2. And is this point at the bottom or at the top? Here's an example where it's at the top. So is that vertex at the bottom or the top of the parabola? The top, very good. So that means the top, or sorry, it's at the bottom, huh? So the bottom, just so you can see this visual, vertex is at the bottom. So we call that a minimum. If the vertex was at the top, then we call that a maximum. Okay? But in this case, it's going to be a minimum. So when we're talking about domain and range, your domain is always the same domain for all parabolas. It's always all real numbers. The domain is your x-axis. It can go, for this parabola, it can go forever left, and it can go forever right. Infinity, forever left, forever right. So that's going to be every number in the world. So we call that all real numbers. It's always the same domain. Now, range is going to be dependent on if you have a maximum or minimum. If it's a maximum, its y is less than or equal to. If it's a minimum, its y is greater than or equal to. If you have a maximum, you cannot go greater than a maximum. So it has to be less than or equal to. If you have a minimum, such as this problem, you cannot go less than the minimum. So it has to be greater than or equal to. And then you're going to have the y value, because it's range, the y value of that vertex, which here the y value is 2. So we want that, let's see, domain range, part C, question 2, part C. So we're going to have all, so it's got to be either A or C for the domain. And then we need that y value is 2 from the vertex. So it's going to be all real numbers, the domain. It's a minimum, so y is greater than or equal to. And then the y value is 2. So you're going to use that. So that was question 2, part C is choice C. So that was showing that the range will define the maximum and minimum. So you're going to use that notation when it's maximum, minimum. And then you're going to look at, it's got to be the number from the y value of the vertex. Okay? And then your axis of symmetry, that means the line that goes directly in half through that parabola. If I was to cut this parabola down the middle, what number is it going to go through? So it's the x value of the vertex, always x equals. So on this given problem, I want to cut this parabola right down the middle, the vertical line. It's a vertical line. It's a vertical line. Axis of symmetry is what kind of line? Vertical line, very good. So we want to draw a vertical line through the middle of these parabolas. So for the blue graph, let's see, the vertical line goes through what number? Axis of symmetry. Axis of symmetry, vertical line goes through what number? Yeah, 0. So notice it's going to be that x value of the vertex. So axis, just to give you that visual, of symmetry is a vertical line that cuts through the middle of the parabola to make it symmetric. And it's going to be the axis of symmetry equation is x equals the x value from the vertex. I ran out of letters there, but it's going to be the axis of symmetry equation is x equals and the x value from the vertex. So in this problem for the blue graph, our x value is 0 in the vertex. So your answer would be See, part D is the axis of symmetry. So it's going to be x equals 0 at x value of the vertex. So we've talked about transformations. We talked about axis of symmetry. We've talked about domain and range. We've actually already talked about this question. Opens up means no reflection. Opens down means it flips over to be a reflection. So again, opens up means no reflection. If the parabola opens down, there is a reflection. So does this graph here have a reflection? Yes or no? No reflection. So it opens up, and then that vertex is at the lowest, the bottom of the parabola. So it's going to be opens up and minimum. And then we've been talking about vertex. That middle point here is 0, 2. So that's going to be choice B here. Okay, so hopefully this helps you kind of have a summary so that you can answer the rest of these questions on your Google form for parts of a parabola and quadratic transformations. So use the picture of the graph to help you, and then that dashed line is that parent, x squared, which is what I had in red here for the Desmos. So the red is the same as that dash line on the Google form. And then if you forget what we talked about, you can always rewatch this video, pause, whatever you need to do, as well as on the Google form, it has all of the notes and the breakdown of what we just talked about. Okay? All right. Thank you so much. Let me know if you have any questions. Email your teacher if you need to.